Hello, fellow foodies. Welcome back. Dr. Cassandra Quave here, your host for Foodie Pharmacology, the science podcast for the food curious. This week, we're going to explore some big questions around the origins of our food and how food connects people from across the globe. We'll also dig into some of the latest science on crop wild relatives. Our guest for this episode is Dr. Colin Khoury. He's a crop diversity researcher who spent more than 20 years trying to understand the state of diversity in our global food system. His collaborative work brings together multidisciplinary expertise to inform conservation strategies for crops and their wild relatives, to develop conservation indicators for international agreements, and support evidence-based decision-making towards a more sustainable food systems. Colin received his PhD from Wageningen University and holds posts at the International Center for Tropical Agriculture, the Department of Biology at St. Louis University, the USDA's Agricultural Research Service, and at the Botanic Gardens Conservation International. Thanks so much for coming on the show, Colin. It's great to see you.
Oh, thanks so much. I'm so happy to be here.
Yeah. Well, I've recently come across your work, and first of all, you have some amazing scholarship happening, lots of really high-tier fascinating papers, and I'm really eager to dig into some of these. Why don't we begin with this concept of food origins and what the global connection looks like?
Great. Let's start big, and let's start historically long, let's say, over many thousands of years. Sure. So I actually became interested in the subject in a certain way for political reasons. I was working for the International Center for Tropical Agriculture on questions about how interdependent countries are in terms of crop diversity, or what is called genetic resources in that field. And the question was, does a country like Brazil need to negotiate with a country like China to get diversity that they need to breed new crop varieties for Brazil? Does China need Brazil? Does the United States need the Netherlands? Does India need the United States? And on and on and on. And there is in that field let's call it a general understanding, or even an intuition, that we need each other in terms of crop diversity. But there isn't actually a lot of evidence or science around that. And so we were working to ask the question as to whether you could put some information behind that. And one way to do that would be to track the flow of genetic resources. That is, where seeds fly across the country, across the world, and who uses them. Turns out that information is actually very hard to come by, although it's getting better. And I can talk about that further if you'd like. Another way to do it is more of an estimation, and it has to do with what we know about where crops come from. That is, originally where they come from, where they were born and raised, let's say, historically, where they were domesticated, as we call it, and where, because of the amount of time that they've been there, typically not only hundreds but thousands of years, where their diversity tends to be the richest.
So these would be called crop centers of origin, right?
They are, yeah. They've gone through a whole series of name changes as we've become more savvy as scientists, I suppose. So they originally were called centers of origin or centers of diversity, and that goes back to Nikolai Vavilov and other folks over 100 years ago who were biogeographers who were starting to understand where food comes from in its original sense. They're now more commonly called regions of diversity, or primary regions of diversity. And that diversity is there not only because that's where crops evolved, but that's where their wild relatives, especially the progenitors, that is, the wild plants from which those domesticates came, are still there, or hopefully still there, if they haven't been eradicated by more recent issues like habitat destruction and climate change. And so the estimate that we were trying to do was to understand where crops come from in their origins, and then where are they important now. And so if we take an example like Brazil and China again, we know that Brazil is one of the biggest producers in the world of soybeans. We also know that soybeans originated in China or in East Asia. Peanuts, on the other hand, are from Brazil, but China is the biggest grower in the world of peanuts. And so the comparisons that we started to do was try to understand where do things come from originally, and therefore still really do have a lot of genetic resource diversity, and then where are they grown now, and also where are they eaten now, and just the whole idea of those connections as they've come across the world over thousands of years of the movement of plants and people and livestock and all of that. The big picture story is that we're incredibly interconnected over this long-term history between where crops come from and where they're eaten and cultivated now. In fact, there is no country in the world that eats or produces food that really only comes from its own region. There are certainly countries that eat more, you might call them traditionally, that still have a lot of their food coming from the region. Countries like Cambodia, in terms of eating a lot still of rice that comes from that region. And then there are other countries that eat almost nothing from their own region, like here in the United States. And I'd be happy to talk about what we do eat that comes from our region if you'd like.
Yeah.
That might bring up a question, though, which is this a good trend or a bad trend? And that is a very complicated, and I would say too simple of a question to ask. There are great benefits of this history of movement of plants and animals around the world, and there are also some challenges and difficulties in terms of human health, sustainability, equity, lots of different challenges. But in general, if you want to talk in economic terms, it tends to be that the wealthiest countries in the world eat and produce food that comes from other places originally, and the least wealthy countries in the world tend to eat the most traditionally.
So, has anything come out in your studies with the kind of global trade disruptions of COVID-19? Did that reveal any major weaknesses in this trade system?
Another fabulously large and ambitious question. Thanks. Well, I should qualify that. A couple of different things. I should qualify that this work was done pre-COVID, and so I haven't looked too much lately into disruptions in terms of food and the movement of food through trade, which has been written about and thought about quite a bit, or at least predicted to be a major issue. I don't actually know now, as we start to do kind of backward-looking questions about the impact of COVID over the last year, how severely food trade has been affected. It's turned out that the global food system has been more resilient, I think, in most cases or in many cases than we thought. But I should also qualify that the question about where food comes from in this larger sense that we were looking at was not only just about trade, that is where it moves now. It's really that longer term question. So for instance, here in the United States, when I say that we mostly eat or mostly produce food that comes from somewhere else, that those foods, they may have arrived here and been produced by American producers for a couple of hundred years even. Like for instance, we are, the United States is the biggest producer, or our biggest crops are corn, soybeans, wheat. A lot of, so those plants really come from other parts of the world, and a lot of their genetic diversity arrived here in previous time periods by immigrants, by plant explorers, by folks who were filling up the seed bank and all of that. And so it's being produced by American producers now, and it's being eaten here, for instance. We also export food, but the bigger history of how it came and when it came and all of that is a history of movement, of immigration from a long period of time. It's not a story simply of recent trade, that your avocado that you're eating right now came from Mexico and it just came here. It's a story of that longer history and trend.
Great. Well, and when we think about crops of North America, what are some examples of our crops? I know that we have a native caffeine source in North America, which is the Yopon holly, an ilex species, which grows here in Georgia where I live. But I have a hard time listing lots of, North American crops that are in global trade right now. Like, do you have any examples?
Yeah, sure. And I'd also actually very much like to talk about those examples that most folks don't know about, including myself, really. And so let's go there. So if we were to unpack the majority of what Americans eat and take out everything that didn't come from this part of the world, we would end up with a diet that would be pretty light and pretty slim. The exceptions are, in the long-term history sense, many thousands of years ago, domesticated by native peoples, are sunflower. And if I can talk about sunflower just for a minute, because sunflower we also consider to be a crop that's not that important, that it's eaten during baseball games, and it's grown by grandmas for flowers, and that's basically it. But that is a huge myth. In fact, sunflowers are incredibly important, particularly as a food oil. And perhaps 10% of the oil from plants around the world is from sunflowers. It's very important in Eastern Europe, in the Mediterranean, in many cases just behind olive oil or equal to it. It's important in Southern Africa and Australia and many other places. So important contribution from this part of the world to the rest of the world and to here. And so that, I think that's our most recognized, celebrated ones. But other domesticates from this area are one type of pumpkin that's called the ovifera type. And both of those crops were domesticated somewhere in eastern North America, probably along the Mississippi River area. And then a number of other crops that we really just don't eat now anymore that come from the quinopod family and devil's claw and a couple of other things. Now, more recently, there was a number of other domestications of plants that we know and love a lot more on the dinner table. And those include cranberries and blueberries. It includes pecans and a number of other basically fruits and nuts. And they're sort of still recent domesticates, really, in sort of the bigger picture, a couple hundred years old in terms of really being bred and starting to travel around the world. Sugar maple, couple other things you might not even consider exactly a crop because they're more wild harvested. Okay, so that's our contribution here. Now I should say around this part of the world, that is from Mesoamerica, just south of here, there is a lot of domesticates that are some of the most important foods really in the world. And we have some diversity of them that's been here for many thousands of years as well through trade by native peoples. And also some of their wild relatives are here, wild relatives of beans and corns and squash and chili peppers and lots of fun stuff like that. And then there's all the plants that you mentioned, which are really just not known at all in our global food system, unfortunately. And what's kind of fascinating to me and complex is trying to figure out why not. And sometimes the reasons are they seem reasonable, like they are very difficult to breed because of their own biological systems or day length sensitivity requirements, issues that farmers really have to deal with and their constraints. On the other hand, that's often just because they haven't been worked with very much by plant breeders. And then there's just a lot of reasons that seem completely stochastic. They're just people didn't pick them up, or there was random stuff that happened for religious reasons. For instance, when the Europeans arrived and considered them to be religious ritual plants and such, and so they were not allowed to be grown, and they just sort of disappeared for those reasons. And so if you start to build a list of what potentially could come from here that could serve the world in terms of amazing foods that would be good for people's nutrition, for more sustainable food systems, perhaps, the list becomes much, much longer and much more interesting. And I have a plant that I'm trying to grow here, it's just barely kind of on the margins of where it should be growing. It really should be a little more east of here too. I'm here in Colorado, which is called Apios americana, potato bean or Indian bean, which I'm absolutely obsessed with. It's one of those plants that should be much more widely available. Why? Because it's a tuber, a starchy tuber that provides great calories, but it's also high protein because it comes from the bean family. And there is an association between peoples or cultures of the world that eat tubers and that are protein deficient. And so if you had a tuber system that was also high protein, it could be quite an amazing plant.
That's great. Another North American plant that I think of is the chestnut, the American chestnut, which provided a major source of food, but was wiped out with the blight. I mean, we have very small chestnuts here. But I wonder how many other crops might have been, or potential crops might have been, you know, kind of pushed to the back of the line because of disease spread with introduction of other foreign crops, with pest introduction.
That's a fabulous question that I think should actually be researched more too. I've really never seen that question asked across all of these what we call incipient domesticates or sort of domestication is not an either or thing. It's not either corn or wild plants. There's this whole spectrum in between, and with all of those plants, which ones had suffered because of disease issues. Butternut is another related variety that also has pretty serious disease issues around it. And then another interesting question I think to ask there, which is being asked more, is in the disruptions that have happened in the last 500 years or more, how have some of those disruptions played out for some of these plants in ways that we didn't think about, like changes to the animals that used to disperse them or their pollinators. And so it's not exactly the crop itself that suffered as much. It might still be there in the forest kind of waiting around, but it doesn't have the pollinator, or it doesn't have the disperser that it used to have. And in the tropics, that is really a real trend and a real issue.
Yeah. Well, it makes me think again, I mean, everything is so interconnected. So if you think about the decline of butternut and you think about the decline of chestnut, what impacts that had also on wild game in North American forests, which is also part of the food system. So it's all really interlinked. We had a really fascinating episode with Dr. Sandra Knapp, who is an expert in the Solanaceae family. And when we think about plants in that family, think of like potatoes and chili peppers and eggplant, tomatoes. But there are actually all of these other edible species within that family that are really restricted to certain regions of the world where they're kind of locally grown and consumed. And I'm trying to think about this on a broader scale. Like there are lots of crops that could potentially be developed, but overall, and I believe you have a paper on a recent publication on this as well, is there's this sense of homogeneity in which foods we eat across the globe. And I was wondering if you could talk a bit about that and what does that mean for food security when we're just all growing and eating the same kind of monocultured foods?
Yeah, I'd be glad to. Thanks. Before I do so, if I can mention that being from an institution from Colombia, I've had the pleasure to get to know one of those solanaceous fruits that is, again, just should be more widely available, because if you're a person that likes acidy flavors like lemonade, this is, believe it or not, kind of a tomato relative that provides the most incredible lemonade-y drink. Ooh. And in Colombia, a culture that tends to enjoy the pleasures of life, I think this is made into a number of different types of drinking, including adding various alcohols to it. The plant is called, or the fruit is called lulo, and it's just incredibly dangerous looking. It's got spines and spikes and strange orange color. It really looks like
all
many
the plant defenses.
Fruits.
Yeah.
What you should not be eating. And it turns out underneath it, within it, is this incredible lemony flavored food.
Wow.
So that also, if you don't mind me weaving just for a moment, I think another reason why some plants have not made it on this global list as they've moved it around are, again, an inherent biological thing, but that could be worked with. And that has to do with storage or shelf life and the ability to ship and transport. And so lulo is one of these fruits it's difficult to send around because it has a thin skin and gets bruised easily and those sort of issues. But if a little bit of work was done to either understand how to ship it in ways that they've done for tomatoes or bananas, or to thicken its skin a bit, then it could travel further.
That's amazing. It makes me think of pawpaws. I have a pawpaw in my yard. I don't know if you've ever tasted those before, but the same issue is like they have this amazing flavor, but do not store or travel well. So you don't have incorporation in larger scale trade.
One of the ways also, by the way, that I've seen industry start to figure out how to do that is by processing and freezing. And
Yes.
so,
Hmm.
for instance, through the acai
Hmm.
boom, which is, now this plant from South America, from Brazil, which is a palm family, is available in smoothies across the world. I think it's largely processed and then frozen as basically a meal. And I think that could be done with papas probably as a
Hmm.
way, if we can't figure out how to thicken their skin a little bit so that they're a
Yeah.
little more shippable. Anyway, shall we head back to the other
Yes.
side of the
Yes.
equation, which is homogeneity?
Hmm.
If you don't mind, I'll tell this story through my own process of where I arrived at this question. So I am actually a conservationist as a background. I'm one of these generalists that have a botany, a genetics, and a conservation background. And at the time I was, and it turns out 15 years later, I'm still obsessed with some of these big questions or even assumptions, or even at this point, if you want to use sort of internet speak, let's call them even like memes in our field. And one of them is that we've lost a tremendous amount of diversity in the foods that we have eaten historically over time. And there is a famous quote that's very often repeated in scientific literature and the media, very common. And it says that we've lost 75% of the diversity that previously existed. There's a related one that also says that we only eat a very small number of crop species. Sometimes it's 9, sometimes it's 12. It's around there, and sometimes it's 3, if you will. But it's the basic idea is that it's too little. And at some point, I thought, who made these numbers, and could we start to investigate that and figure out what the is that the real number? How
Hmm.
how how many crops truly feed the world? And um, one of the ways that we looked at that was we looked at dietary data, or in fact, food supply data, which is a proxy for dietary data that has to do with, in countries around the world, what is available to be eaten.
Hmm.
That's national production plus imports, and then you subtract out everything that's sort of lost along the way in terms of waste. And we have that data, luckily, across the world for the last 50 years, and it's publicly available data. And so it has all kinds of course, issues with it, but it's really the longest and best longitudinal data set that we have about what's been available for people to eat. And the first thing I wanted to do was simply try to measure how many crops have disappeared out of that list over 50 years. And I was shocked and disappointed, I suppose, but not in the bigger sense, to find that no crops had disappeared over 50 years. In fact, crops had come onto the list and nobody had disappeared. And I thought, what is going on? Is these statements that I've been saying for the last number of years completely wrong? And as we started to unpack it, the story, of course, became more complex, but also much more interesting. And the story there is, first of all, this data set, as good as it is, it really doesn't measure those locally important or formerly locally important foods that are disappearing. It's a data set of the winners, if you will, of the global commodity crops. And what's interesting out of there is that those global commodities are spreading and becoming more global over 50 years. And there are crops like quinoa on that list that really, even a couple of decades ago, weren't really very global and are becoming much more global now. What we found through that was, as these crops were spreading across the world, these national food systems were becoming more diverse. And that was sort of surprising to me at first, but more diverse for global commodities. Again, we can't measure what we don't know. So underneath that, there's probably a lot of loss. As these food systems were becoming more diverse for global commodities, they were actually becoming more even within them. What that means is that the most important food in the diet, whatever it was, for instance, rice in Thailand, which 50 years ago was providing up to 90% of the calories, was actually becoming a little less important in the diet as other staples like wheat and potatoes were starting to come in. And so there was this balancing out of these global staples within the national food supplies. And as both of those happened, as richness increased and as evenness also increased, everybody started to eat more similarly. And that's what we call homogeneity, is that food supplies across the world, across 200 different countries, look a lot more similar now, 50 years later, than they did 50 years before. And that goes back to another one of these memes, which is that we have like this, we have a global diet, or a Western diet, or a Mediterranean diet, if you will, from some of your research, and that those ideas are silly. Of course, there's a huge amount of diversity underneath that it's very hard to say. But I think what our research told us is that the idea of a global standard diet is much more real now, 50 years later, than it was 50 years ago. That is, these things are starting to become like real things. We are starting to basically, no matter if we live in Kuala Lumpur or Dublin or Colorado, we're starting to eat much more of the same foods.
Interesting.
Again, go ahead.
Oh, I guess the question is, and this may be a level of a layer under the data that you may not have access to this level of detail, but I'm wondering, when we say that, for example, a crop like corn is being traded and this is being consumed at a certain rate within a country, how much do we know about the processing of that food? Because a whole corn cob is going to have different nutritional values than, for example, something that's made into corn chips or something that's been fried or prepared in some other way. Do we have that kind of information? Because that can also, when we think about the Western diet, it's often associated with like high fat, high sugar, unhealthy kind of diet. But you can start with the same starting ingredients in some cases and go two different directions with that final food that you're consuming.
Yeah, thanks. Another great example of that is potatoes, which,
yes.
Which in their, let's say in their natural form, are really, if we want to use these dichotomies, let's call it a healthy food. Its primary consumption globally is through French fries, which has a tremendous amount of added fat and salt. And so if we're going to use the dichotomy, we might, even if it's a wonderfully tasty food, we might put it on the other side. Yeah, well, so what we know, we don't know, basically. In that sort of global data, we don't really know how processed the foods are for the most part, other than if we're going to use the example of corn, we do know how much of that is sugar, that is what's become a sugar product out of corn, that is high fructose corn syrup. How much is a grain corn? We know how much is going to forage and feed, and we know how much is a cooking oil. And so there's a little bit of that there. And so one of the great winners, let's talk about the winners of the last 50 years. There is one group of, let's call it a food group, one group of crops that are the tremendous winner. And if you don't happen to already have it in your head, I mentioned it a little bit before in terms of sunflowers. It's the oils.
Okay.
And yeah, and so, and when I say winners, I really mean where it was 50 years ago to where it is now. And so the biggest winners of all are crops like soybean, palm oil, sunflower, canola. Some of those crops went from very little consumption around the world to absolutely tremendous. And so we see that as soybean, but for instance, but we're really talking about soybean oil or soy cooking oil. It's not that the world has started to eat so much more tofu or soy sauce. It's really an oil issue. And that actually gets into technological innovations. It has to do with folks having figured out how to stabilize cooking oil so that it wouldn't go rancid quickly, so that you could bottle it without refrigeration and put it on a shelf in a country, in a community that doesn't have electricity and all of that stuff. With sunflowers, There was also innovations in terms of the profile of oils in terms of saturated and different types of unsaturated fats, which stabilized it as a high burn point or high temperature cooking oil, which then could be used to create, admittedly, some of my favorite foods, which are tortilla chips and things like that are now cooked in a fairly healthy oil, sunflower oil, because that oil can take those temperatures and not go rancid. And those were innovations, by the way, that happened in Russia and in Eastern Europe long ago through mutation breeding and other things. And so another global history that we're all interconnected. And then Frito-Lay here discovered and said, hey, we got to use sunflowers. This is the future.
It is hard to kind of nail down a single answer for these broad questions because, there have been so many different historical, patterns that have emerged and things have been moved around and technologies have emerged, as you mentioned, in different areas and then incorporated in other areas. And it's just a meandering stream of information and flow of genetic resources. Yeah.
That sounds like my research that you just encapsulated, I suppose. And interestingly, I've been really trying to figure out what that narrative is that carries through it all and makes some sense. And after 20 years, I'm still trying to figure that out. Like that story of globalization, basically the story is globalization, but globalization from 12,000 years ago to the present. Yeah. Is that story, again, a good story or a warning story? And it's just not simple. And of course, all scientists like to say that, it's complex and the answer is not simple, but I would like it to be understandable and meaningful. And so if you allow me, I can try to sort of move forward a little bit to the length of where I've gotten to with this.
Yeah.
As much as I can within too big of a story to even start with, really, in an hour of talking. But what is really clear to me is that the movement of all of these plants have benefited people in other parts of the world. Sometimes just like fundamentally and so deeply. And it's very hard to metric that. You can talk about contribution to their calories or protein or vitamin A, but there's also just cultural importance and depth to that. You go to the places that are the most, let's say, quote unquote, traditional in the world, countries like Bhutan, in the Himalaya region, and their national dish is a bowl of chili peppers with cheese on it, and chili peppers are from this side of the world, and so it's it's not just calories or whatever. It's everything that combines to make culture, which is in terms of food, which is taste, and it's also underneath that all kinds of things in human health, bad and good, that contribute to us and who we are. And so I'm really a believer that greater story of exchange and movement has had a lot of positives. And my experience of working with farmers and on farms for many, many years too does give me the feeling that farmers do, as a general concept, exchange and trade and move food. There is also this human worry about new things, which, let's call it self-preservation, like the wild tomato examples, like lulo, like there are things that look like you should not eat them, and turns out they are edible, but it's probably good to be cautious about what they are. And as a note, there are also things that are not edible and you should not eat out there. And so I guess us humans have this interplay within us that we both need and want new things in contribution to our diets, to our culture, but we also are afraid of newness, I suppose. And there's some balance there. But the winning, I think, has been, in the end, it's been incorporation of new things, and that is new foods, and that is still going on across the world. The second question, though, is what has been lost along the way. And that is the part that's so much more difficult to actually measure, but the indications are that it's also been major and tremendous. And if you're not eating one thing, if you are eating one thing, then you aren't eating another thing. And so our diets are wonderfully diverse in this global way, but they're also much less diverse than I suppose they were or could have been if they were hyper-local and pre-globalization, and especially pre-agriculture, if you want to go that far. And there have been certainly big costs to that in terms of human health and sustainability. We can argue, since agriculture is now the world's largest ecosystem and the world's biggest contributor to climate change and all kinds of our most existential questions. And then there's the questions around equity and that story of the movement of foods, I do believe, has had a lot of trading and exchange that has been generous, and there has also been a lot of movement and exchange that has not been that has been associated with taking and utilization without really asking, but also has been the movement of people through slavery that has brought and the creation of whole industries based around slavery that have needed food. And so we've brought a lot of tropical foods like breadfruits and other things to keep those very unjust societal systems going. And then those foods stay there, and then they contribute in positive ways to other people. And so the story gets recomplicated again. And it's extremely hard to imagine going back, if you want to call that, and saying, we're no longer going to eat this food in a certain place. It's just, I see it as sort of an unstoppable movement of diversification across the world, even as we lose this localism. And so the third question, or the third kind of idea that comes up, is what do we do about this, or where do we go from here? And I certainly don't have any answers to that, but I hope and I do see coexistence in a certain way, at least in terms of what people want. And if I can unpack that just a bit, I think that these global commodities, things that ship super easy and fast, that have long shelf lives, that we don't particularly have a real connection to anyway, like flour. Like, we want flour, but we don't, like, many of us don't even know what flour is really beyond that, like what plant it comes from or anything. I think that those are going to be these global commodities that are shipped around, and not a locally based diversification kind of idea. And people want them to basically be available and cheap. And those working within diversification within wheat and crops like that have that challenge, how to do that. On the other hand, I see that folks have a desire for connection with local and for connection with culture in other spheres. And for instance, here in Colorado, it's very much within our microbrews, within the beers, and within local vegetables, for instance. And that tends to be, so that's either stuff that has a kind of a local flavor or connection, a denomination of origin, if you will, or it's not that shippable. It's greener stuff that is it wastes. And so I kind of see this division where people are going to be ordering their food, wheat, flour, whatever, and it'll come by whatever the Amazons of the future are to your house by drone or whatever it is. Yet people will still go to the farmer's market for their vegetables and their other locally based products. And I hope that somehow between those two things that there is some way of looking at diversity and keeping it within this food system, both within all the species or the different crops and stuff, and then also within them, that is the varieties and then all the things that they're made from, all the different products. So.
Yeah. Wow. That's an amazing synthesis of a really big dynamic system. Um, and I think I agree with you where I think we're very divorced as a population from the origins of many of our staple foods. You know, people think of sugar. A lot of people probably think maybe they think of sugar cane, but a lot of this actually comes from sugar beet today. So it's like, how does this white substance end up in my pantry? Like, where does it actually originate? We're so far from that process. And another source of food we haven't really gotten into are also wild vegetables, which is not as common in Western diets, but definitely in the Mediterranean. There are many examples of um, I don't know that they would really be called, crop. They wouldn't really be crop wild relatives, but they are edible species that are spontaneously occur. I'm thinking of like chicory, although chicory also is a crop in other areas,
Mm.
um, dandelion, and other kind of spring greens. But when we think about classification of these groups, so we have kind of our commodity crops, you have your leafy greens and your fruits and your nuts and your oils. Um, where do crop wild relatives come into play? And I know this is a major focus for your research. And why are these relatives important to our food systems?
Thanks. Yeah. Okay, so it turns out that these global commodities, if they're grown on huge expanses of land, in monoculture especially, they end up sooner or later having some vulnerability because of their uniformity. And we have examples of that. Sometimes we learn from those examples, sometimes we don't. But here in the United States in the 70s, there's really a profound example that changed the culture, let's say, even when we lost about 25% of the corn due to genetic uniformity, especially in the South and the Southeast. And so, and if we want to go further back, there's the Irish potato famine, and there's a lot of other examples that, even though they all have to do with other complications as well, fundamentally there was an issue of genetic uniformity leading to genetic vulnerability and a pest or a disease figuring that out and causing major loss. And so what hopefully we've learned through that process is that we need genetic diversity within our global commodities. We need varietal diversity and we need genetic diversity within the varieties even. And one of the ways that we can find some of that diversity that's becoming more and more popular and more common are from the wild cousins who didn't go through the genetic bottleneck that happened during domestication to become the wonderfully big and easily edible, but sometimes not that diverse crops that we eat. And in terms of all the different crops that are commodity crops, but also all the different crops that are cultivated now using crop relatives within their genetics, it's almost all of them. This is a far cry now from some sort of alternative technology, and crops like tomatoes or potatoes absolutely just couldn't exist at a large scale anymore without introgressions from crop relatives, particularly for pest and disease resistance, which is still the most important contribution that comes from crop relatives. But they're also useful for a lot of other things, even including higher nutritional quality. And so they are, ironically, this incredibly important genetic resource for modern crop breeding, they being wild plants that grow out there in forests or in pastures or sometimes in traditional farmlands. And so it's this fascinating thing, and it doesn't really surprise me that this has become one of my major interests in life, because that interface between wildness and agriculture is what's always, I suppose, interested me, and where I grew up also was this space between farmlands and urbanization and wild spaces, and so these crop relatives are exactly that. And the big questions are, can we figure out who they are and what we need in the future, and can we protect them either in gene banks, as we call that, in repositories, or also in their natural habitats, so that they'll be around and they can contribute to agriculture. Now, that's just one side. As we mentioned, these plants also have all these other values. They are directly harvested, like wild chili peppers along the Arizona Sonora border are a tremendously important cultural food. That's a wild plant that are harvested. Why? Because it's incredibly hot, and it has a different form of heat than the cultivated chili peppers, and people value that, and they'll pay more for it. They're also important for ecosystem services, as we call it. That is, they have their own ecological functions in nature. They contribute to the soil, and they contribute to pollinators, and all of those things. And so we're ever more trying to figure out how to celebrate them, how to let people know about them, and how to conserve them. Here in the United States, we've been working very strongly on that for the last 5 years, or even the last decade, including now publishing the biggest update of what we consider our most important crop biorelatives for food and agriculture, which end up being about 600 native species, relatives, of course, of the sunflower and the squashes, as we mentioned, and the pecans and the cranberries and blueberries, all of those, and where they live across the United States and what their conservation issues are. It turns out that they live everywhere. There is not a place in the United States that doesn't have some kind of wild relative of a crop that we eat. It includes in your backyard, just everywhere. But there are places that are richer than others in terms of diversity, and some of those places are highly urban places or near urban places in the northeastern United States or around the mid-east coast, like in the Washington, D.C. area. And so there's really major concerns as urbanization expands about them. On the conservation side, it turns out that in some of those groups, we're doing a pretty good job of conserving them, like the sunflowers. That's been a lot of efforts in the public sphere to protect them and to make sure that they're available. In some of the other groups of plants, they're really not very protected at all, and we need to do a lot more work.
Wow. It's amazing to think I can go out my back door and see some of these possibly. And they are such an incredible living resource, a living genetic repository for the future of crops. Where are you taking your work in the future? Do you have, kind of as we wrap up, what are your next steps? Where are you going with this work?
Wow.
I love throwing these tough ball questions at you because you give such beautiful, complex answers.
I always feel so myopic about my own future.
Yeah.
I am excited by organizations increasingly looking at how they can work together, partly because they can't do it on their own. And so there's a large and ever largening group of institutions that like to and want to protect and educate about plants, and that are those are botanic gardens, and those are also land managers like the Forest Service and the Bureau of Land Management and the Nature Conservancy and other folks. They are also the public seed bank system here in the United States and elsewhere. And I think there's an increasing recognition that as incredible as our science is, and as much as the scientific world knows about how important these plants are or how threatened they are, we're basically losing ground. And that's a sad thing to say, but I think it has to be recognized that I don't think it's not that we're not moving like quick enough for what we need. We're not moving quick enough even to slow down really the processes that are happening in any major powerful way from what I can see from my perspective. And I am an idealist, by the way. I think I am. So,
a bit pessimistic. So where would you send students to, like, if let's say if they're graduate students listening to this right now, what advice would you give them? Like, how can they make an impact, whether, in securing our future food systems and wildlands?
Well, thanks. Just to wrap up about the organizations, I think that so for instance, if you want to protect our wild cranberries or sunflowers or whatever, doesn't it make a lot more sense that all the different organizations that might be interested in that, and the botanic gardens and the seed banks and the land managers, might figure out how to do that together and use the best of science, use the best of genetics to know where the diversity is and where it's unique, and make sure that we're focused on the most important places. And so that's what I'm excited by. I think that there's momentum that's happening there a lot. To your question about what to do, like I am certainly one of those people that's really worried about the loss of a basic like plant scientists, like botanists and taxonomists or ethnobiologists. I think that those are declining still, unfortunately. So I do think that we need people to go into that. But I will also posit that some of the most important things to really make progress don't actually have to do with conservation itself. They really have to do with people figuring out our energy needs to make them more sustainable, to move away from fossil fuels and somehow stem climate change, to deal with a whole bunch of things in the food system that could lessen waste and reduce sort of the impacts of people in terms of how much we need to produce in so many places. Like, for instance, just decreasing vegetable food waste through, I'm really excited about new products that can extend shelf life, for instance, in strawberries and bananas and things like that. All of these things that you might not think are exactly conservation, but if and how we make progress in those ways, they have very strong and clear impacts on the side of protecting crop and plant diversity. Finally, I think the hardest one of all, our food systems and the societies that they support, I do not think are inherently diversity supportive processes. And that has a lot to do with economics and how we've organized things. And I don't pretend to have any like really clear idea about exactly how to resolve that, but I do really think that a frame shift on basically how we view diversity and how it's needed does have to happen somehow. And in a certain way, I think that's actually almost like a moral or ethical kind of frame shift, an empathic revolution, as some have called it. And that has to do with education, as being a teacher. It has to do with experience and getting kids outside. It has to do with a billion different things that are not like being a scientist in a direct way. And so there are a million ways, I think, towards that goal if people are interested in sort of this question around diversity, sustainability, human health, and equity.
That's great. No, you're right. There's so many, you can help out the process through many different angles. Yeah. Well, Colin, where can folks find out more about your work? Are you on social media? Do you have a website you can refer them to?
Yeah, sure. So my publications, I really try to make them all available online and open access. And so if you type in my name, you can probably find them very easily. And I'm sure there'll be some links here on the podcast and on my Google Scholar. I have a Twitter account under my name that you can find me as well. I'm also really happy to chat with folks if you want to get in touch with me. It's always a pleasure.
That's great. Well, thank you so much for coming on the show. This was a really fun conversation. I learned a lot.
Thanks, me too.
Yeah. You've been listening to Foodie Pharmacology, the science podcast for the food curious, recorded on Skype. You can find this episode and all of our others on our website at foodiepharmacology.com or on the Teach Ethnobotany YouTube channel. Thanks so much to our producers, to Rob Cohen and Christine Roth from Co-Conspiracy Entertainment. And thank you to you, the listeners, for tuning in and learning about these fascinating aspects of our food systems. Stay healthy out there, and I'll see you next time.